Let's have a look at how we expect you to do your homework. Now notice that we're not telling you how to do anything because you're taking this course because you want to learn, and your learning style may be different from other people's learning styles, but let's make a few suggestions anyway. Let's go to Unit 2.2.2, which focuses on a little bit more theoretical ideas related to linear transformations. And if you go down to Homework 2.2.1, this particular question is what we call a true-false question, because the answer to this question is either it's true or it's false. Sometimes our questions are always, sometimes never questions, in which case there are three options for the answer. And sometimes they are just purely computational. We'll look at one of those a little bit later. Now, in this particular case, I happen to know that the answer is true, so I'll mark that. And once you mark it, until you click on check, it will not be recorded as an answer. And, oh, I got this one wrong. So let's change that to false. And notice that you have multiple opportunities to answer the question, even true-false questions. So we'll check that. And now I got it right. Now, it's very easy to sort of say, well, I got that right and I think I know what's going on, and then to just move on to the next question. But often the real learning is in the answer. And often there are multiple ways of answering this question, and the way we show in the answer that we give somehow puts a spotlight on the material that helps you learn. So we very, very much encourage you to go ahead and then show the answer. Now, since this was a true-false question, you shouldn't really just answer the question, but you should also provide a proof for your answer. So you should really prove that this particular function is not a linear transformation. So the idea is, before you look at the answer, you justify it. A proof is a justification. And then you may want to look at a video, in this case, of Maggie proving that it's false. Or you could look at the written answer that happens to also be given here. And in this particular case, we even attach a PDF of the answer that Maggie develops as part of the video. And because of the way edX works, embedding the video here is a little bit problematic if you also want to see the downloadable video and or the transcripts. And as a result, we have a link here to the end of the week where you can see the embedded video with transcripts and possibly download the video to your computer. Let's hide the answer. And one comment is that some people learn by looking at the answer before they answer the question, and that's okay too. Something to note is that up here there is a bar that shows you your progress as far as homework is concerned for this particular unit. And then you can also go up here and click on progress. And what you notice here are all of the different units along the x-axis, and then a bar graph as to how much you have already answered in the different units. It even tells you within the separate sections what problems you have and have not answered yet. And also notice that if you happen to answer a problem wrong, you're encouraged to actually go back and fix it. Anyway, let me now go to a different section. Here in section 1.3.2, there are homework problems that are a little bit more computational in nature. And when you give the answer here, one thing that you may notice is that there really should be parentheses around these boxes to make them into column vectors. And it turns out that mixing the mathematical typesetting with boxes in which one can enter results is a little bit problematic on the edX platform, and therefore the parentheses are missing, and you're going to see that throughout the course, so just kind of get used to it. And you can check, and then you can show the answer. And in this particular case, we don't have a detailed answer because it's a relatively straightforward computation.